right, so suppose that I wanted to do number 54 and 1.4, which says the demand for gasoline can be modeled as a linear function of price. What does that mean?
It means the price is the output.
Wait, what?
Wait, what was the linear model for price?
So the demand for gasoline can be modeled as a linear function of price.
Oh, okay, so as demand goes up, price goes up.
No.
So as demand
Price goes
down,
up.
Means price is the
Price goes up, demand goes down.
Yeah.
that's
I don't know which way it goes, but I do know that price is the, what did you say?
output.
input.
Price is the input. Right, because demand is a function of price.
Right.
Means demand is your output and price is your input. Okay? And then it says some more stuff. So it says if the price of gasoline P equals $3.10, the quantity demanded in a fixed price is Q is 65 gallons. I don't know why they picked Q, but they did.
For quantity of demand.
That seems legit. So apparently that should be a Q axis, right? And then what else are they saying? They're saying, oh, if the price rises to $3.50 a gallon, the quantity demanded goes to 45.
Those are like totally points.
Those are like totally what now?
Points.
Yeah. Those are points. You guys with me on that? Right, so these are literally the input-output pairs. So the first thing they want me to do is find a formula for Q in terms of P. Okay, I should be able to do that. Right? So that should be, how do you do this? What do you need? Yeah, first things first, find a slope. Okay, so what's the change in the price and what's the change in the quantity?
Change in price is 40 cents.
Change in price is $0.4. It would be best if you kept the units all the same, right?
Makes sense.
And then what about the change in quantity demanded?
20 gallons.
20 gallons,
So negative 20 gallons.
specifically down, right?
Yeah.
You guys see that? Okay, and so which one do I divide by the other one?
Doesn't matter. Change of Y, change in X. So change in Q.
Nice.
over
Change in price per,
Yeah.
or sorry, change in demand per change in price,
Yes.
right? So your slope then is negative 20 divided by 0.4. Which a little back of the brain will get you
50.
negative 50.
Yeah. Negative.
Okay, cool. All right, so that's your slope. Now, where do you get your equation for your line?
Just pick a point.
One slope, one.
Yeah. Pick a point,
Mhm.
right? Which point do you want?
310, 65.
Sure, the first one,
Yeah.
right? Because who cares? So, what should I be writing?
65 gallons equals negative 15 of the price plus B.
Oh, you're doing the weird way.
Oh.
Okay, sure, we can do the weird way. So, there are two thoughts that you could have. They're both valid. Mika is apparently looking at this and thinking y equals mx plus b, right?
Mhm.
And then she's going, well, it's not really an x and it's not really a y, and I know m,
Mhm.
right? So what's m?
M is 50.
Negative 50.
M's negative 50. And then
Y is actually Q.
y is a q, right? So what's one of the q's? Well, she says
65.
65 is one of the q's. And then in here I could put in a
$3.10.
3.10. And then I should have a plus b, right?
Right.
Yeah.
Yeah? Okay. And then what?
Solve for B.
Yeah, you just.
Yeah, and then you solve for B, right? So you get out of this B is
220.
okay. Cool. Okay, so is that the answer? 220. Circle. Move on with life.
No, that's just the y-intercept.
No, that's just the B part, right? So what's your equation for your line?
65 equals negative 5310 plus 220.
Uh,
Oh.
Q of P equals negative.
There you go. It should be a function, right?
Oh,
So it should be
right.
Q of P equals, and then what was your slope? Negative 50 still. And then what's your x?
P.
P.
Yeah.
Right, because x doesn't mean anything in this context,
Right,
right?
right.
I'm doing like quantities and prices. There is no x. It doesn't mean anything. And then what else do you need?
Plus 220.
Plus 220. Okay, so that's the like y equals mx plus b approach.
Right.
How else could you have done that?
On slope.
Yeah, you could use a point slope approach, which is what I would have done personally. So I would have said, okay, so Q of P is minus 50 times x, oops, x,
P.
P, minus, what's one of your P's?
310.
310. Like just pick one, right? And then plus the Q that goes with that P. Cool? And if you multiply that thing out, you'll get this thing. Cool? Questions, Steele? Okay, so that's part A. Part B, explain the economic significance of the slope of your formula. What does your slope minus 50 mean?
What's the,
Demand in gasoline per gallons.
For every whole dollar that is increased in the price of gasoline, the consumers buy 50 gallons less of gas.
Dude, nice. Get that out of the back.
No,
Got that out of your
it's an
brain.
even number.
Nice. Yeah, that's awesome, right? It's negative 50 over 1, right? And then units are gallons per $1, right?
yeah.
So that really is increase of $1 goes with, right? Decrease of 50 gallons. And then if you want to say that in like really honest human speech, you might say something like, for every increase of $1 in price, the demand falls by 50 gallons. Cool? Okay, so that's your economic significance of the slope. What's your economic significance of the q-axis and p-axis intercepts? Whoa.
So when price is 0, you still have a demand of 220 gallons.
Okay, so that's this one, right? That's your intercept over here. That's 0 goes with 220, right? That's at $0.
The demand for gas is 220 gallons.
Right.
Which is like,
So that's, if gas was free,
we
the
don't
demand
have-
would be 220 gallons.
That's amazing.
You see that? What does that clue you into?
The model's not accurate.
Yeah, this model's probably dorked around 0. Right? There's like some area on which this model works, and that area probably doesn't include 0.
Well, I just I guess so.
'Cause I'm probably, like, I'll go out on a limb and assume that if gas was free, people wouldn't use an infinite amount of gas, right? But they would probably use a lot.
Well, I would think, my mind goes to the point of like, if gas were to ever be 220 gallons, it would be free. If the demand for gas was ever 220 gallons, it would be free. As opposed to saying, if gas were free, we'd only use 220 gallons.
Yeah, that's a reasonable flip. In this problem specifically,
Yeah.
they want me to think of quantity as a function of price
So you
and
think
not
of quantity
vice
first,
versa.
So you think of quantity first, and then you can come up with the price.
Yeah,
Or just
so-
I mean, yeah.
you're kind of flipping an evaluate problem for a solve problem,
Okay,
right?
okay, fair enough.
Which is totally fine. And they, like, the function they gave me is clearly invertible. Like, I should be able to think about this the other way too.
Mhm.
You guys see that? But that's what you're doing. You're flipping that thing over before you think about it.
Right.
It's not wrong, just a weird interpretation.
Yeah.
Clearly not the, like, not wrong, just not the one they're looking for.
Right, right.
And then the other one here is, what's the economic significance of the other intercept? So first, where's the other intercept?
Yeah.
Yeah, that's going to be down here someplace. Where is it?
$4.40.
So that's 4.4 goes with 0. How'd you get that?
I don't remember, I probably just plugged it into the thing.
Yeah, plug 0 in for Q, right?
Yeah.
Into maybe here, and solve for P, right? So what's that tell you?
If gas is $4.40, then
No,
the
it's
demand
gonna
for
buy it.
gasoline is 0 gallons.
No one's gonna want gas.
Gas is too expensive, who wants to buy it?
Yeah. Of course, that's crazy pants, right? Because the way we've built our economy relies entirely upon having gas for things, at least in the short term, right? Like, you might not pay $4.40 for gas for very long, right? Because once gas hits $4.40, you'll pretty quickly buy an electric, right? Yeah, unless you have a really good reason to drive diesel, like you just spent $220,000 on a new piece of equipment, right? In which case you'll probably use it for a while, even if gas is really expensive. Kind of with that?
Yeah.
Question?
No.
No? Okay. I would say this model is at least a little bit broken in those two ends. And that happens. Like, everything's a model, right? Like, every time we make a model for some economic situation, one, it's a guess anyway, so it has some error bars on it anyhow. And two, if you go out past the spots where you calibrated things, like I calibrated these at like $3.50 and $3, right? So this might be good down to like $2.50 and up to like $4, but it's probably not good past those values. It's probably not even good past the values that I used to calibrate it. It might be good in between them. You guys see that? So there's this, in statistics, there's interpolation, which is using your model on points in between the ones you use to calibrate it. That's okay. There's extrapolation, which is using your model on points outside of the points you use to calibrate it. And that's always problematic. Cool? It's not wrong, just problematic.